Yeah, thanks a lot. Our hackathon topic was actually a small Android application with Couchbase and Thin Gateway, and this development kit is kind of spin-off from there with several ideas how you can make your application. Basically, since we are not working with Couchbase professionally, we want to have the possibility to develop quickly in mixed teams with different hardware. Configuration must be very easy and very maintainable. It must be portable, reproducible, and I would call it maybe, let's say, Subway development team. So if I have several minutes in Subway, I should be able to turn it on, write the code, and if it works or not, just test it. If it takes me half an hour to set up the environment, it makes no fun. So what we're using for that, basically Vagrant setup. Vagrant is just a tool to create and configure virtual environments, and it's really easy to use. All you need is initialization for the first run. It creates you a small minimalistic Vagrant file. It's just one file. After changing that file according to your needs, you can just start it. You can log into it with Vagrant SSH. You need the name only if you have multiple nodes set up. Without it, you don't even need a name. Then if you change your configuration, you can just reprovision it with simple provision command. Even on running setup, you don't have to turn it off. If you have major configuration changes, then you'll probably want to stop it, destroy all created virtual machines, and then start it up again so that you don't get any unstable configuration or not working configuration. So how does a Vagrant file looks like? It's just Ruby code with variables. It's not valid Ruby code because variables here are just placeholders for the values which you can either write down directly into the file, or which would be even more reasonable to have it in your local configuration file, which doesn't have to be tracked in your version control system. And what's important here is, at first we have the global configuration, like where to get the box from and how do you want to how the Vagrant should call this initial box which it will start. Then you have any amount you won't have or your system can handle. And from that you can just define your single Vagrant boxes, and the names must be unique, of course, because you should be able to differentiate between your virtual environments. And configuration here is specific for a single node, where you can define your IP address, you can set memory, you can enable or disable graphical user interface, you can run it headless, as in our case, because we don't need GUI for our Couchbase server. And you also get the VirtualBox name, and probably the most interesting part is the provisioning part, which you can do with shell provisioners, Chef, or in our case we used Puppet. To show what the placeholders means, I used YAML file for the configuration because it's very simple and easy to read. And just simple example, you have here in your Vagrant file, you require a YAML package, and then you load YAML file, and then you can get all the properties you need locally, like your network devices, ports you want to enable, buckets for the Couchbase, if you want to use Thin Gateway or not. It goes everything into your YAML file, and then it will be read through by the Vagrant file. And next step is Puppet, because provisioning is probably the most interesting part, where the most part of the work happens. So if we look at the provisioning part, we only need to tell him where to find modules, what's the manifest, and where it's located. All the facts below are also coming from this local configuration, which can be specific for every single development environment for every single computer. And it's also, it's very convenient. You can just push your variables through to the Puppet level. how does manifest of Puppet look like? You only, in this case, we need aptitude because it's Ubuntu server, and it should happen before everything so that we can download all the dependencies needed for Couchbase. Then we can download and configure our Couchbase and our sync gateways. And the whole structure will look like that, where the most interesting parts are actually the configuration of Couchbase and configuration and templating of sync gateway. So to skip the boring part, we can show some parts of command line interface of the Couchbase, where we basically have all the variables like node IP, administrator port, user password. They all are configured in your local files, and then you need to start with the initialization, where you can also give the RAM to your virtual server. And then we also want to define, we also want to differentiate between our master server and our slave servers. Because only on the master servers we want to create buckets, we want to start sync gateway, we want to shadow the buckets. On slave nodes we don't need that stuff at all. So we just check if the node IP is our defined master node IP, and if yes, we just go through the creation of buckets with you always need the cluster information with IP, admin port, and user credentials. And then we have the bucket information like name, size, replicant. Interesting part, you always, for Puppet, you have to make some conditions. For example, here we don't want to create the bucket if it already exists, because if we provision our system and the bucket already exists, then we'll get Puppet failure. So to avoid that, we make a check, and if in the bucket list the bucket that we want to have already available or is already there, then we don't need to create a bucket. The next condition goes for the sync gateway. So if we really want to run sync gateway, we create a bucket to shadow. And at this point, this bucket is created the same way. The difference between the buckets will be apparent only after we start the sync gateway. And the same here. It's reasonable to start it only after, for example, we can create buckets only after the cluster is initiated. If we don't define this dependency, then we have high chance of crashing the Puppet setup. The same is here. It should happen later. For example, after the previous bucket, so we have a complete chain. And also, it shouldn't happen if we already have this bucket defined here. And if we are not on the master node, but we are setting up the cluster, the slave, we don't need any buckets. We just need to add the server, and we need to tell him where to add it to with credentials of the server we are adding to and credentials of the server which we are adding. So here the same is actually needed only after we initialize the server, and here we also need some try conditions, because we can solve it differently, but I'll show it on the case of sync gateway how it can be done differently. But here try is working better because sometimes Puppet is faster than Couchbase. If the client not really initialized and we start to add another server to it, then it will probably crash. So we give him 3 tries, and after every try he has 10 seconds to rebalance basically for the initialization process. And after that we have our cluster initialized with one master node and basically any amount of slave nodes we want to have. So if we want to have sync gateway, we sync gateway is configured via JSON configuration files, which contain most of the information that you need for the sync gateway. So if we want to make it configurable through Puppet and our local YAML configuration, we need to use eRuby templates for Puppet. I'll show it on the next slide. And for the Sync gateway, if initialization of Sync gateway fails, it doesn't throw the error, it just logs it. So Puppet will not crash, but the application will not work. So to solve that problem, we just run Couchbase client interface with the server info command and getting the status out of it, and we continue only if the status is healthy. If not, we throw exit code 1, and we can do it also several times. And we do it only if there is no process called Sync gateway running. And it's reasonable to do it only after the template was created and processed. So, after all that, we can also take a look at the eRuby template. It's so far pretty simple. I haven't changed the interfaces. I only name the database the same way I name the bucket. And also it listens on the local host with the admin port. And we have a shadow bucket because Sync gateway works slightly differently. If you want to write something into the Sync gateway bucket, you don't write into it directly, but you write into the shadowing bucket. So for that purpose, we created the shadow bucket before. We created the shadow bucket here, the Sync bucket, and we define it Sync bucket, and app bucket is a shadow bucket. So at that point, we basically have a complete working setup. All we need to do is Vagrant app, but the problem we have right now, current concerns are, if you call Vagrant app and time it, it will take you 10 to 20 minutes. And so it's not really convenient for subway work, I would say. That's why so far it fails the speed criteria I actually wanted to fulfill. So after it was pretty slow for 20 minutes, it's not slow, but it's inconvenient if you are working on certain configurations and you want to restart it every now and then. You are looking for responses and you don't want to wait for it so long. So if we analyze the Puppet, what actually happens here, we see that aptitude part is totally independent from our configuration. It's just this part would rather belong into the original Vagrant box, as well as the whole Couchbase download and installation, and also Sync gateway download and installation. We don't want to do this anytime we start our cluster. We just want to change some configurations. So there is a tool that gives us possibility to create our own custom Vagrant boxes. It's called Packer. Packer is written in Go, and I'm absolutely no Go expert, but luckily there are example cases. And first of all, Packer is a tool to create custom VirtualBox images, custom Vagrant images. You can create Amazon cloud images. You can create probably almost every image you can imagine with Packer. But syntax is not intuitive, but easy to change. So far, you have examples. So, for example, for Ubuntu server, there were a lot of examples online. So all you need, having your Packer configuration, is just to run Packer build, and it will throw out the box you want to have. If it's Vagrant or VirtualBox, depends how you configure it. So just to take a small part of the configuration file, the first two parts, variables and builders, were mostly standard, taken from the examples on GitHub. Interesting part starts at provisioners, because with provisioners we can download Puppet with our shell provisioners, and then we can use the same Puppet modules and Puppet classes we have used with Vagrant. the only and using the same provisioners, we only throw out the configuration parts out of it. So this Couchbase provisioner will look almost exactly like our previous provisioners. And at the end, after running Packer, you get your Vagrant box, which is ready for Vagrant. So after throwing all the Couchbase provisioner part out of our Vagrant provisioner part, we'll stay only with two configurations. And if we time it now, the Packer build part is long. It takes us 30 to 45 minutes, even without downloading of actual operational system images. But after that, you have your created new Vagrant box, and from that, to run the configuration, you usually need only 1 to 2 minutes to complete. So that if we take a look at small example, so we can see that all the nodes are destroyed, no virtual machines anymore. And while it's still running, I can conclude that using this combination of tools like Packer to create random Vagrant boxes, Vagrant to build them with Puppet setup, we are able to actually have very small and configurable development setup. This setup is easy to track with version control systems, and you also have your node, your configuration, which is independent from the node locally, and you can deploy in 1 to 2 minutes per node, which is also fast enough in my opinion. And at the end you are ending up with small and tiny, I would say, handy development kit to go. And if we take a look at our current setup, the node 2 is already in progress. You see that first one is already created, second one is almost done. So that as we see, the sync gateway is already running. The whole setup took us slightly more than 2 minutes, and we have freshly configured Couchbase server with I defined 2 nodes. We see that one node is already running, another one is waiting for a balance. We have 2 data buckets which were created or defined via local configurations, and we see that one is a sync gateway bucket, and another one is just a normal bucket shadowing the sync gateway bucket. So basically, at this point, we are ready to develop. 2 minutes and wrong slide. And thank you very much.